Hello everyone, and welcome to our webinar entitled Easily Scale Embedded GUI Applications for ST MPUs and MCUs with Altia Development Tools. My name is Jeff Urkovich. I'm Director of Product Marketing at Altia, and I'll be moderating our event today. Before we get started, let's go over a couple of housekeeping items. If you have any questions during our webinar, please type them into the questions pane of the GoToWebinar control panel on your screen. Please feel free to send your questions in at any time during the webinar. We'll collect those questions and share them with our presenter during the QA session at the end of today's presentation. Now, please allow me to introduce our presenters for today's webinar. Soren Mikkelsen is Business Development Manager for Graphics at ST Microelectronics, and Johnny Slump is Technical Marketing Engineer for Altia. Soren, we would love to have you begin our program with an overview of the features and benefits of ST Micro's MPUs and MCUs. So please take it away.
Thank you very much, and I hope you can hear me loud and clearly. And please go to the next slide. Perfect. Thank you very much. So first of all, my name is Soren Mikkelsen, and I'm working at ST, doing marketing and business development for embedded graphics across STM32 MCUs and MPUs. I'm very pleased to be here today presenting to all of you, and a big thanks to Altia for hosting this webinar, of course. My presentation will be some few slides about STM32 in general, and of course specifically on the graphics solutions we have. And feel free to ask any questions regarding STM32. I hope we can ask or answer most of them during or after the webinar. And lastly, some of you might ask why we are at ST doing webinars with some GUI library partners. Overall, we partner and co-promote with solutions we believe brings additional value to the STM32 graphics solution. That's of course why we are here today. And Altia is such partner, and I hope you'll enjoy the next hour learning more about this. Please go to the next slide. Just quickly on this, so we at ST are very proud to share that we are the #1 general purpose microcontroller worldwide, used by more than 100,000 customers and shipped to more than shipping more than 10 billion units since the launch in 2007, which is of course a huge achievement for us. Please go to the next slide. So why did so many customers, developers choose an STM32 MPU for their product? Here are some reasons behind it. One point is of course the real-time performance you can achieve with our products. Outstanding power efficiency, especially on the new U5 series, which I'll also share a bit about. Our superior and innovative peripherals, maximum integration, and the last and very important point is the extensive ecosystem we are bringing. So one thing is this is our silicon, but on top of this, we are really providing an extensive ecosystem, making it very easy and very fast for anyone to get started on STM32 microcontrollers and microprocessors. Please go to the next slide. Our STM32 portfolio keeps growing, and we keep innovating across different series, targeting a wide range of end applications. And one of them is, of course, embedded graphics. And today I would like to point your attention to 3 series which embeds graphics accelerators for running any kind of UI needs you might have, 2D, 2.5D, 3D kind of applications. The STM32 U5 series is specifically one of them. At Cortex M33, this embeds our newest GPU called Neochrome. And pay attention to the, let's say, the naming Neochrome, which I'll come back to later on to emphasize more on the capabilities of this one. Secondly, we have the STM32H7 series, a very versatile, high-performance STM32 series, which we continuously enrich with the new sub-series. This one also embeds Chromart, as many of you maybe know, JPEG codec and such, and it will also be enriched in the future with newer graphics capabilities. And lastly, the MP1 series, Cortex A7 supporting OpenGL like applications. So here Of course, these are not the only one which are capable of running graphics, but those are covering most of the needs we see out in the field. All excellent products for running smartphone-like GUIs with Altia on top, of course. So I would say that to you, if you want to run an SPI, RGB, TFT, or MIPI DSI display, simple or smartphone look and feel, low power, running from internal SRAM or external SDRAM, Hyper, Octo, PSRAM, or DDR3, we have the product for you. So please have a look at the big portfolio we have on our website. Please change the slide. Thank you. And please press one more time. Great. So if you're new to embedded GUI development, it might seem complex, and it is of course complex. So we at ST, we do not only supply the silicon, we try to build solutions around our silicon, making it even easier and faster for you to start your development on top of our hardware. So we do have an exploded watch here, but it could be a thermostat or anything else, of course. And what we do at ST, we of course have the silicon itself, an STM32 MCU or MPU. Together with this, we supply Cube Programmer, CubeMX, and drivers, HAL layers, and so on, and the Cube IDE as free tools. I'll not dive in too much to this, but it's helping you to configure your microcontroller, microprocessor, to write your code, to generate a project, and so forth. On top of this, you of course need a UI machine, a UI engine, a UI software tool for your PC. One option here is Altia, which runs on top of some STM32 microcontrollers and microprocessors. And I'm sure if you have the desire to run on a specific part number, you can ask them about this. But it runs here. And lastly, you of course need to enrich the graphics engine, the tool, with some bitmaps, vector graphics, to make it look outstanding, the UI. And of course, lastly, you have the display, which you can source from different vendors. So our approach is quite holistic, and this is also why we're here today, partnering with Altia to show the integration and the collaboration between the two of us. Yeah, please change slide. Let me just emphasize on some of the key ingredients of why it's easier to use an STM32 to run graphics. One point is the ChromeArt accelerator. ChromeArt is an graphics accelerator we embed in some selected STM32 microcontrollers to offload the CPU for specific graphic operations. It is a simple drawing, 2D copying, alpha blending, color format conversions as some of them. Please do next slide. We're running a video here, and let's see how smooth it is on your side. But at least it's showing some clouds, some alpha blending, a lot of layers, moving a lot of bitmaps, and you can see the impact of running this kind of application with and without ChromeArt. And on the right corner, you can see the MCU load. Right now it's quite low. So for a framework like Altia, you can run a graphics application like this, utilizing ChromeArt and offloading the CPU, which can be quite powerful for you doing it this way. Please go to next slide. Excellent. Next one here, this is let's say the step up. If you require more advanced drawings, scaling, rotation, perspective, correct texture mapping. So we call this 2.5D, not 2D, not 3D, but 2.5D. And this is a new IP from us we call NeoChrome. It also supports simple drawing, 2D copying, alpha blending, and color format conversions, similar to the ChromeArt. But we have the additional features here. We are also showing in a video if you just press one more time. One more time again, please. Just to give you an idea of what we are capable of with this kind of IP. Thank you. Please go to the next slide. Last IP I would like to point your attention to is the JPEG codec. Many applications requires the ability to run a small video. It can be an instruction video or something else. It could be a few seconds or splash screen or something like that. Many of our STM32s they have the capabilities of hardware accelerating a motion JPEG, so that you do not require any CPU cycles to perform such operation. And just to share the comparison here with the JPEG on and off, you're really offloading the CPU very heavily. Yes, please go to the next slide. Just a quick idea of what you could be using it for. Please go to the next slide. So overall, the STM32 graphics portfolio is quite versatile. On the entry level, we have solutions running on G0. This is a low-cost MCU. And then you can take the step up to the H7, the U5 series, and especially to the H7A3 and the U5-9, where you can run from internal SRAM. So you do not need to run on SDRAM or Octo-HBI or Hyperflash for the frame buffers. And then, of course, the MP1, where you execute from DDR3 RAM. So a lot of options here. And of course, it's up to you with the guidance of the local representative from ST to find the right solution for you. That being said, I'll hand it over to our colleagues or to our partners at Altia, and thank you for listening in.
Thank you so much, Søren. Again, my name is Johnny Slumpf. I am a technical marketing engineer for Altia, and let's get started. So Altia is a leader in embedded graphics with our technology stack running in over 100 million devices worldwide. Above, you can see the logos from just a few of the companies that we've partnered with to bring their user interfaces to life. Altia works with leading white goods manufacturers, which includes home appliances like ovens and microwaves, but also smart home devices, things like home and building security panels. Altia also has implemented graphical interfaces for a wide variety of medical devices for use in both hospital and surgical environments, as well as personal medical devices like glucose monitors and insulin pumps. So what are some of the trends we're seeing for GUIs and IoT? In general, we're seeing a huge increase across the board. They are practically expected by consumers, and it's likely why you joined this webinar. As mentioned, this includes home appliances, smart home, manufacturing equipment, vending machines, food and beverage services, medical devices, and building security systems. IoT has become a dominant thread with more products being interconnected via the internet. Those devices need a way to display that data in a useful format for the user to gain the most benefit. And the most obvious way to do that is with a refined and high quality GUI interface. There's a push for accessibility and ease of use that's opened up by interacting with touchscreens that are coupled with engaging interfaces. These types of forward-leaning interfaces enable your devices to be seamlessly integrated into a user's life. That enables the users to make life safer and more comfortable by controlling and adapting to their environment. So what are some of the challenges for scalable GUI development? GUIs are time intensive to bring to life typically. You have time to market constraints and goals, and sometimes long iteration cycles for those changes. No one wants to cut features or scale things back when they're releasing a new product, but often that is inevitably what happens. So how do you create a single design that runs across multiple platforms? How do customers achieve scalability? Well, some of the biggest challenges are RAM and flash constraints. GUIs typically use the most system resources. It's just the nature of graphical assets. And that additional RAM and flash can be expensive, and it's something we need to be cognizant of. You also want a consistent user interface, smooth animation, possibly with 3D or just 2D or 2.5D, as Søren mentioned. And you want a familiar user interface to maintain solid branding at all levels of your product. Often there are communication gaps between the designers and their specifications, and then the engineers and how they implement them. It often takes too long to iterate and solve those issues and cause issues as you bring your product to market. So why do we want to use Altia Design and Altia Deep Screen for scaling between these devices? The most difficult part of getting a GUI and graphical assets onto a system is interfacing with the GPU. Altia takes care of all of that dirty work. Embedded graphics is our sole expertise. We let you focus on what you do best, which is creating those beautiful user interfaces. You can also have a good collaborative development environment, which includes a multi-document interface with shared instances. Altia can enable faster startup times using compressed images, and in some cases, we can provide a method to get graphics on the display while the GPU is still booting by using two different graphical pipelines. Altia's code generator only adds code that will be used in your design. If a certain module isn't needed, like real-time 3D, then we don't include it in the build and the code becomes smaller. Altia can also interface with any operating system or with no operating system at all on a bare metal implementation. We have run on Linux, FreeRTOS, Integrity, Kyle, MQX, Nucleus, to name just a few. Altia provides an integrated system to optimize your graphical assets. Our binary asset manager automatically chooses an optimum color depth and compression algorithm for each graphical asset in your design. We support the full range of GPU graphical and compression formats, including things like ETC, ASTC, DXT, RLE, etc., and it's all automatic. Of course, the user has full control to override that in special use cases. Altia gives you a tool to create a UI, and that UI will appear on the display pixel perfect. As I mentioned before, requirements are often changing and new ideas come to the surface. Altia allows you to quickly prototype and get those features on hardware to meet deadlines. All right, real quick discussion on some quick case studies. First with DMP. Altia enabled a skinned UI that was fully integrated into DMP's high-end and flexible security and smart home system. It provides the core user interface for their entire system. Over in the smart oven or white goods category, this was brought to life on a low-cost device. Altia leveraged a 4-bit graphics pipeline that no other graphics vendor even would consider. Altia already had a specialized solution ready to go, and we brought a delayed product back to life. We were able to deliver on time, and these ovens have been in production with many variants over the last several years. And lastly, Medtronic. One Altia benefit is that we offer a well-tested graphics engine, which is written in straight C, which simplifies the certification process. In addition to enable globalization, we provide modules for font engines and text shaping, which enable all languages. This includes both open source and licensed options. And lastly, we'll talk about something that's in production on the STM32F4. This is a device for tandem diabetes care. It is a mass market insulin pump. One success for both Altia and ST was the groundbreaking use of the first touchscreen incorporated into a compact wearable insulin pump. Again, the efficient C source code allowed streamlined certification in the medical field, high reduction in the average engineering time, and as well, Altia in this case was able to offer end-to-end professional engineering services to support the best quality UI and UX experiences. Let's talk about the Altia toolchain for the ST platforms, where we can go from pixels to production hardware in literally minutes. You start with the best-in-class graphics tools, whether that's Sketch, Figma, Photoshop, 3D tools like Maya. Those graphics are then imported into Altia Design, which is our GUI authoring environment. And once you are in Altia Design, you add in the various animations, you put things into layers, work with 3D effects and various shaders if you need them. And once your design is ready and laid out properly in Altia, you then use Altia Deep Screen, which is our C code generator. That C code generator will interrogate the entire design, again, write code for the parts of the graphics engine that are necessary. It'll bring those shaders in, and it will also look at all of the assets in your design and optimize them for the particular hardware. That C code then is compiled into a library, interfaced with your business logic, and then loaded onto the device of your choice, in this case, STM32. Well, this is the GUI we're going to be looking at on live hardware in Altia Design in a few minutes, so I'm not going to spend much time here. And we're going to be looking at two different platforms. The high-end platform is the STM32 MP1 57F. It is a dual Cortex A7, has a lot of RAM on it, and it's running the OpenSD Linux operating system, and it's running on a 4-inch TFT. And this rendering is done through the OpenGLES pipeline. The low-end platform we'll be looking at is the STM32H7. It's a single Cortex M7, more resource constrained, but you'll see we still get a great product out on a 4.3-inch TFT, and this is running bare metal, no OS. For the rendering, we will be using Altia Mini GL coupled with that ChromeArt 2D graphics engine. Right, now let me get my screen reconfigured and we will get the video up. All right, here we go. All right, here we have the STM32 MP1 version of that medical demo inside of Altia Design. If we click on that layer manager object, which controls the display properties, you can see two important settings. The width, the height at 800 pixels and the width at 480 pixels. And if we go into run mode, we can actually interact with the model via touch or mouse. There are buttons along the bottom, and we can see the various screens, the main screen, the body mode, and the about screen. And we will dive into each one of these. On the main screen, we'll talk about the data part of the screen, which is created in a list format down at the bottom here. You can see it's all inside of layer 4, which we can toggle on and off. And we'll expand this mode in the navigator and investigate how this content was created. Each of the columns, the time, pulse rate, etc., are each created from what we call a multi-line text object. This allows you to control the text in a line-by-line method. We click the measure button, you can see that the object scrolls down and a new line is independently created, and then that updated content is added. Another object that's interesting to look at is the body screen. This content is a 3D model of the human body. It's fully contained within layer 17 of the model. This content is created from a 3D object, imported using a standard format from a tool like Maya. And this allows the OpenGLES GPU to render it in real time. You can see that it has the 3D model, it has a camera object, and then a group that actually holds the mesh for that 3D body. Now, if we look at that 3D object, you can see that there are a whole host of animations. And we can also see the materials that are applied to the surface of the model and the shaders that are used. If we click on the shader body, and you can see the vertex shader in the window here. This is the code running on the GPU, as well as the fragment shader. And all those shaders are fully configurable within Altia. You can also look at an alternate implementation where we use a deck of images to create what we call a flipbook animation. This is useful for situations where the GPU may be more limited or where the hardware doesn't even contain a 3D capable GPU. We'll keep this in mind for the H7 version of the model, which we'll review later. Now, if we go to run mode and we can head over to the about screen. There we go. This layer contains the full image sequence that morphs between the star field, the text, and the Altia logo. Even on hardware that may not have a full-fledged GPU, our tools can enable a rich user experience across high and low-end devices. All right, now we're going to take a look at the same model running on the MP1 hardware. Here's the model running. The UI was displayed after the system booted into Linux. And we will go ahead and press the measurement button so you can see the addition of new data, the smooth scrolling on the screen. Again, this is using that multi-line text object that we discussed earlier. We'll take a look at that 3D body model. Again, this is running real 3D. It was imported using the FBX format from a Maya model directly into Altia Design. In Altia, the animations were added and the various materials and shaders were applied. This model is using real-time rendering with Altia's compact 3D engine. Similar to what's used in portable video games, it's a very efficient yet still feature-rich environment. And then finally, the about screen. Again, this is a flipbook animation, a sequence of several hundred images that are automatically compressed into smaller images that are able to be displayed in quick succession for a smooth animation. Now we'll look at the low-end device. This is the compact version of the model for the H7. This target does not require the layer manager for the display, so we can control the image size by looking at the canvas size. So you can see it's 272 pixels wide by 480 pixels tall. And instead of using layers, we control the screen content with a multi-level deck object that has cards inside of it. So you can see that there are 3 cards. Card 0 is the main screen, the measurement screen with the graphs. Card 1 is the body image. And card 2 is the about screen with the star field. We also have 2 other groups available to us. The header, which is the top content with patient information, notifications, and then the bottom menu, which has those 4 navigation interaction buttons along the bottom. So if we look at the list content, these are no longer using the multi-line text object. They've been modified, and each column is using a series of 5 single-line text objects for each data type. They're grouped by columns so that when you add a new reading, they animate downward, and then the new data is temporarily added to the placeholders above before being added back to the main list text objects. There are often several ways to implement the same feature in Altia, and this enables your GUI to be consistent across platforms as you scale between different hardware devices. Now, if we look at the 3D style body model, it's the same technique as what we described for the other device. Instead of a 3D model, this is a flipbook animation. There are a couple hundred images in the sequence, and these were captured directly from the 3D model by Altia, and then automatically added into a larger deck to provide the sense of real 3D, even on lower end hardware. This allows our users to create consistent branding across all of the different platforms that they may be using. And lastly, let's take a look at the About screen. This animation is identical to the STM32MP1, except the size of the images has been changed to fit the display dimensions and the number has been reduced. We're still using a flipbook animation that's rendered frame by frame from flash memory. All right, and we'll take a look at this on the hardware. All right, you can see the graphics are shown almost immediately as we're not running an operating system on this device and there's no 3D GPU to initialize. Here we see the main measurement screen. We can add measurements and see how the animation looks identical to the high-end device, but it's just been implemented in a more optimized way within Altia. The body screen, hopefully this video is showing smoothly, but it's a completely smooth 2D animation sequence that appears to be 3D, even though it's only 2D. Each of those 200 images is compressed for low flash utilization and then decompressed using the 2D GPU automatically as part of our optimized pipeline. And lastly, the About screen, also running an image sequence that is then blended with real text on the screen. All right, let me get back to the presentation. Okay. All right, so what are some of the features and benefits for the MP1 specifically? So Altia unlocks the full potential of the OpenGLES GPU. It's a fully 3D capable pipeline with real-time rendering of models, textures, and shaders, as we just saw. It enables modern complex designs. This MP1 allows the latest Altia features, which is composite timeline animations, which is multiple timelines controlled by a single animation, blended 3D animations, where you have kind of two 3D animations that you can cross back and forth with a third animation, things like programmable scene nodes, differential 3D import to speed up the process, as well as responsive and dynamic layouts. For the H7 series, we use the highly optimized Mini Geo graphics engine here, coupled with ST's ChromeArt graphics accelerator. The Mini Geo graphics engine is highly optimized for code and gives you the smallest footprint and the fastest execution. Coupled with the ChromeArt accelerator, it allows fast data copying with its dedicated DMA, integrated pixel format conversion, and efficient hardware-based bitmap and font transparency blending for those fonts live on the screen. For all of the platforms, Altia unlocks the full potential of the ST hardware. We have custom graphics pipelines for, of course, OpenGLES and then the Mini Geo ChromeArt. We have automatically optimized code for the smallest footprint and fastest execution, no matter what device you're running on. Deep Screen itself can enable layer-based animations, which further offload the CPU onto the GPU. And then our binary asset manager can encode your graphics in formats that allow the GPU decompression without any CPU overhead. And lastly, we have support for anti-aliased font engines and text shaping options like FreeType and Monotype. Cloudware is a system that allows you to take a design created in Altia design and upload it to a hardware target that is located in the cloud. This is a pretty new concept, and it allows fast iteration and testing on actual hardware without having to purchase development boards initially or spend weeks setting up that hardware locally. The ability to do this is really amazing and has sped up development and testing for many of our customers. It's now possible to get your design running on remote hardware in literally minutes. Kind of 4 benefits of Altia Cloudware I'll talk about. You can try before you buy. So there's no upfront cost to test designs on multiple hardware platforms to help you choose which ST part is best for you. You can save time. Instead of having engineers spend days or weeks bringing hardware up, you can get those things running in minutes for quick testing. Also gives you great collaboration. The distributed cloud-based tools allow you to use a unified development stack to ensure that everything is always properly configured for all of your engineers. And lastly, you can test today. You can bypass that wait for development boards and get things tested in the cloud immediately. Lastly, why is Altia great for GUIs on the ST platforms? Altia can use the same design with 0 or minor changes and generate code for various ST platforms. Our optimized code will ensure you get the most value and performance out of your chosen platform. And lastly, no matter your industry, Altia provides a well-defined and trusted path to get you to market quickly. So with that, thank you for your time. We're going to turn it back over to Jeff and see what kind of questions we have.
Hey, Johnny, thank you for that great presentation. And thank you, Soren, for your presentation, both very informative. We have a bunch of questions, and I think the first one's going to be for Soren. And the question is, what is the maximum display resolution for the STM32? For example, is it 1920 by 1080?
It's a very good question, and it's not a simple answer I would put. It's very dependent on the whole architecture. So one part is, of course, the microcontroller or the microprocessor, but are you executing from internally or are you executing from externally? What is your frame buffer strategy here also? One example is the MP1. You have DDR3 here. And here you are also able to run quite high resolution. If you go up to the one referred to here, 1920 times 1080, so 1080p resolution. It's a really high resolution for this MP1 platform. So it's very static UI you are able to do here. You of course always need to have this in mind when you build the UI. The larger resolution you go on, the richer the colors, the more let's say the more relying you are on the platform and the performance you can get from it. On the H7s and the U5s, you can go up to 1280, 800 maximum resolution. That's also quite static UI, and then a bit below, of course. So it's very, very dependent on what kind of UI are you doing, what is your hardware setup, what is your frame buffer strategy, all of these combined. So overall, do we support this resolution, so the 1080p? Yes, but very static UI, I would say. Yeah.
Thank you, Soren. Looks like our next question is going to be for Johnny. What is the frame rate that Altia GUIs can achieve on hardware?
Yeah, so Altia Deep Screen understands all of the capabilities of the GPUs that we're deploying to and all of the elements of your graphical design. And therefore, we can optimize the code to connect those two in the most efficient manner. You know, every GPU and embedded platform has different strengths, as Soren mentioned, when it comes to driving graphics quickly. So, you know, what things impact frame rate? First, the size and number of the graphical assets. Of course, this is part of the discussion that we have with our users. And then compressing those assets so they can be first transferred from flash to the GPU very quickly, the bandwidth across the memory interface. And then along with that, you want to choose formats that the GPU can decompress using hardware where possible. Both of those things are, you know, we can help you with automatically by using the binary asset manager. I mentioned this briefly during the presentation, but the binary asset manager looks at all of the assets in your design, looks at the color content, and then looks at the GPU and says, okay, what are the formats we can use to ensure that it's a lossless compression format for those graphics? And it will automatically perform that for you. In some cases, you may need You may want to use a lossy format, like it's a flipbook animation that's running very fast, where you don't see each individual pixel as it's moving by quickly. And BAM allows you to use all of those features very seamlessly. The Altia graphics engine, in addition, has been optimized from the ground up and is really very fast. It's adaptable to different memory strategies, and we support all of those compression and pixel depth algorithms for each GPU. So Altia will let you run as fast as the hardware will allow.
Great, thank you, Johnny. Next question looks like another one for Soren. Which display interfaces are supported by STM32 microcontrollers?
Yes, good question. I will start from so SPI. We support simple SPI displays where you have a DRAM inside, and then the step up would be through our FMC, where we support 8080, 6800 parallel interfaces. Step up would be then the RGB TFT interface up to 24-bit, and lastly the MIPI DSI interface.
Great, thank you, Soren. Johnny, we're going to come back to you. This one is about Binary Asset Manager, which is something you just covered a few seconds ago. Does Binary Asset Manager work for 3D only?
No, and it's a great question. The Altia Binary Asset Manager works on all types of GPUs, even if they only support a 2D graphics pipeline. So in this case, it definitely works along with the ChromeArt GPU. It even works on systems without a GPU, so very low end, by using a software-based graphics pipeline and choosing the smallest pixel depth format and performing that basic compression.
Great, thank you. Johnny, we're going to stay with you just for the next one here. You mentioned Mini GL. What's the difference between Mini GL and Altia GL?
Yeah, it's a good question. There's a pretty good distinction there. Altia GL is a full-featured pipeline that has a very diverse set of tools available with all the bells and whistles for the fastest implementation and ease of use. On the flip side, Mini GL is a hyper-compact graphics engine that is stripped down to support the majority of the most popular features, but reduces some of the extended functionality that isn't required for most GUIs. We have several very large systems running on Mini GL using lower cost hardware, but no one can actually tell that it's actually running on a minimized system. For instance, the smart oven that we discussed earlier, that uses Mini GL, while its big brother on the high-end system runs a full Linux kernel, yet they look almost identical other than the screen size and image formats. And lastly, on Mini GL, we can customize the system to actually not use dynamic fonts, but to pre-generate the font glyphs being used. So you're saving that processing at runtime on some systems.
Fantastic, thank you, Johnny. Question for Soren. Are there future product releases within the H7 family, and what are they?
Yes, I briefly said a bit about this. Yes, we are going to enrich the H7 family next year. I cannot share that much, but definitely for graphics, this will be a good addition here for many of you. Yeah.
Great, thank you, Soren. Back to Johnny. Here's one, Johnny, for you. Does Altia support 1080p resolution?
Yeah, we do. Altia doesn't have any constraints on the resolution supported. So we've run on systems from very, very small, just a few hundred pixels in each dimension, all the way up to several thousand pixels wide in kind of a wide format, kind of 4K output.
Great, fantastic, thank you. And while we have you, Johnny, we'll just stay with you for the next one. What other ST parts does Altia support?
Currently, we have deployed on quite a few ST parts. So in the STM32 series, the F4 and the F7, which have been around, We also work on the STM32H7 and the STM32MP1, which we discussed today. Two other parts are the STM32L4 as well as the ST Accordo 5 series.
Great, thank you. Let's see, so back to Soren. What is the main difference between neochrome and chrome art?
Good question, and it can be confusing. But if you, let's say, high levelly chrome art, you can do the simple drawing, so 2D copying, alpha blending. So when you have multiple layers, you have some transparency, it can accelerate this, and color format conversion. Color format conversion is example is that you in Flash you have one format and then you have a second format you use on in your frame buffer, for example. You can do the color conversion here or in the output for the display. If you take a step up, Neochrome has the same capabilities as Chrome Art, but on top of this, you're able to do more advanced drawings. You can do bitmap scaling and rotation, and have, let's say, perspective correct texture mapping also of a bitmap, all done in hardware. So it is let's say a step up. If you have those kind of requirements, this is an excellent choice for you.
Fantastic, thank you. Johnny, for you, how does Altia optimize for different GPUs and platforms?
Yeah, it's a good question, right? Because we do support a really wide variety. So some platforms have specialized formats that are required, and the Altia system was built up modular in that way, so that when we interface with a new format type, it literally just plugs into the underlying graphics engine seamlessly. We almost never touch the graphics engine itself. It's the kind of a modular approach where we plug in different pieces to extend it. Similarly, Altia Design is very flexible and allows several different ways to build the same type of user interface, which is kind of what we talked about during my presentation, right? Each one of those methods is kind of optimized to a different style of GPU. Altia Design provides kind of a Swiss Army knife type of approach across platforms, but the majority of platforms actually reuse the same type of tools over and over.
Great, thank you, Johnny. Johnny, this one's also for you. How do I configure my software to run with the hardware in Altia Cloud?
It's pretty simple. You actually don't have to. It's all done for you in the back end by Altia. It's fully configured and automatic. I think the best answer probably is if you're interested in looking into that some more, just head over to altia.com/cloudware and you can get all the information you need.
Okay. Last question. Thank you everybody for these great questions. If we didn't, well, I have one more question to ask here, but I want to say if we didn't get to your question today, we can reach out to you directly afterwards. With regard to the last question, how can I learn more about Altia Design? Johnny, do you want to take that one?
Yeah, sure, I can take that. If you want to learn more about Altia Design, we have a learning platform called Altia Learn. It's a series of video and interactive courses where you work with the tools and kind of learn how everything goes together in a kind of a streamlined fashion, focused on the needs that you have. So yeah, it's a platform called Altia Learn that you can access to get learning and all the things you need to get started with Altia.
Yeah, that's great. And we just released that. So we just had a launch of Altia Learn about 2 weeks ago, and it's open to all. If you just come to our website, altia.com/resources, you can choose Altia Learn under that, and you can just request a login, and it's open to everyone, so we can get some exposure to our tools and people can learn how to use them a bit. So good stuff there if you'd like to learn more about Altia Learn and Altia Design. That's it for the questions. I want to thank you, gentlemen, and thank everyone for joining today. Great questions. If you have any other questions, please email us at info@altia.com and we'll get right back to you. Thank you, everyone, and we wish you a wonderful day.